Morning, my name is Olinto.Rosales. I am a Venezuelan technologist and inventor, winner of national awards for my inventions in the area of educational technology and research such as the Humberto Fernandez Moran Awards and the Eureka University Awards. Actually, there are many recognitions received for my works, but for reasons of time I can only tell you about the most important ones. In 2014 I was accredited as a Class A Innovator by the PAE 2014 Research and Innovation Stimulus Program of the Ministry of People's Power for University Education, Science and Technology of my country. My entire career of more than 20 years as a researcher, inventor and innovator is documented by numerous press reports in Venezuelan newspapers and in various web portals that you can consult through your preferred server. Now in this video, more than talk about me, I want to talk about my project to find a vaccine to eliminate the coronavirus. This project is called Prokaryotic Vaccines to Eliminate SARS-CoV-2. But to explain my project, we must first talk about the structure of the coronavirus and how some vaccines are currently being developed to eliminate this virus and end the pandemic. The parts that make up the general structure of the SARS-CoV-2 coronavirus are, as in all animal viruses, the envelope and the nucleocapsid. In the envelope there is a membrane protein, M, that forms a matrix in contact with the nucleocapsid. In addition, the envelope contains the S-glycoprotein, which forms the spikes responsible for adhesion to the host cell. Inside the envelope is the nucleocapsid, which is the viral genome made up of RNA. To explain how many of the vaccines currently being developed to combat the SARS-CoV-2 coronavirus, I will take as an example the vaccine in the experimental phase of the prestigious University of Oxford in England, to develop it using technology based on the creation of a viral vector. Pay attention. It turns out that the University of Oxford, to develop its vaccine, first took a virus that affects chimpanzees called adenovirus. Then he modifies it so that it's not capable of causing disease. On the other hand, after studying the viral genome of the coronavirus SARS-CoV-2 and its glycoprotein S, the University of Oxford detected which were the genes of the SARS-CoV-2 coronavirus capable of generating the glycoprotein S. He then extracted the genetic code for the S-glycoprotein. Then with genetic sequencing techniques, they managed to introduce into the viral vector that had previously developed those genes of the SARS-CoV-2 coronavirus so that it was able to induce its glycoprotein S and create a new genetically modified virus, which is the virus used in the vaccine. Once the experimental vaccine has been developed, testing on volunteers begins. What is expected is that when the virus contained in the vaccine enters, it activates our immune system by generating the necessary antibodies to fight the SARS-CoV-2 coronavirus. Thus, when our body comes into contact with the SARS-CoV-2 coronavirus, we have an immune system that is sufficiently prepared to prevent infection and prevent the person from having COVID-19 disease. I want to tell you that the University of Oxford vaccine is one of the best initiatives to fight the pandemic. However, for a vaccine to be approved as valid, it must pass many tests and trials that ultimately determine not only if the vaccine is effective in generating immunity to the coronavirus, but also that it will not cause serious side effects in those who receive it, and these side effects are determined not only in months but in years. It is important for me to understand that many of the vaccines being developed today are based on genetic manipulation of Mother Nature to create new viruses. But I've chosen a new, faster and safer way to find a coronavirus vaccine, which I've called prokaryotic vaccines. So it's time to explain my project to you. Inside us there is something surprising and wonderful. In our digestive system there is what is called intestinal microbiotics, which is the group of bacteria that live in the intestine. Intestinal microbiotics comprises 100 billion microorganisms, within which there are at least 3,000 species of bacteria. Intestinal microbiotics can weigh up to 2 kilograms. Only 1/3 of the microbiota is common among humans. The remaining 2/3 are specific to each person. The intestinal microbiota has been associated by several studies with functions such as the metabolism of some carbohydrates and specialization of the immune system. Now you may ask yourself, how can bacteria in our digestive system help us get a coronavirus vaccine? Well, I'll answer that by asking you another question. Did you know that bacteria can defend against viruses? When a virus called a bacteriophage tries to reproduce inside a bacterium by injecting its genetic material, Some bacteria have developed advanced defense systems to prevent this from happening. The team of molecular biologist Guillermo Montoya at the Novo Nordisk Foundation's Protein Research Center at the University of Copenhagen has mapped out for the first time the mechanisms that bacterial cells use to defend themselves from attacks by virus or other bacteria with the molecular scissor CRISPR. Specifically, the researchers have shown how a bacterial cell attacked by a virus activates a molecule called CoA, which, in turn, activates a complex of CRISPR Cas called CSX1 to eradicate the attacker. As for COVID-19, studies show that the entry of the coronavirus produces an increase in inflammation that causes alterations in intestinal microbiotics. The lower the diversity, the greater the inflammatory response. Therefore, we would expect a worse prognosis of COVID-19. This is a demo, but research into the defense mechanisms of bacteria against viruses is only just beginning to be discovered, so I believe that nature can still surprise us much more. That is why in my project I have designed experiments that could determine if there are bacteria in the intestinal microbiota that can secrete antigens such as proteins, molecules or segments of molecules that are tolerated by our body, and that can degrade or eliminate viruses, thus contributing to strengthen and complement the human immune system. These antigens, if not tolerated by the human body, will be the basis for the development of new vaccines against the SARS-CoV-2 coronavirus. I invite you to think about the extraordinary scope of my proposal. Finding these substances produced by bacteria in our intestines would not only allow us to solve the problem of the current pandemic caused by the coronavirus, but would also give us the vaccines and therapeutic solutions for future pandemics, as well as generate cures to other viral diseases such as the common cold or HIV. Given the great economic crisis in my country, it is necessary for me to call on the leaders of the World Health Organization and the United Nations to join efforts in supporting my initiative, hoping for the best results. To continue developing my project, I require resources and money to hire highly qualified personnel, scientists and researchers, and the payment of specialized laboratory services to do the experiments. That is why I invite you to make donations to help me. Thank you very much.